Hello, hello, and welcome to the evening stream. I'm trying out some new things here. So you may have noticed everything's different. That's because I'm not at home anymore. I'm home. I'm back home in Iceland. So stream's gonna be a bit different today. We're gonna do the same content, but we'll be doing it from here. Hey, little Annie. My #1 fan. I hope the audio is okay. I tried fiddling with it a bit, but you know, we haven't tried it with this setup, so might take a couple of sessions to get it working, but it sounded okay to me in the recording, and I hope it'll be good for you on the stream as well. My internet connection isn't quite the same as it is back in Sweden, and as you can see, I have no green screen here, but you know, I hope this will be good. The setup is also going to be different. This is a Windows computer, but due to company policy, I am not allowed to update it to the latest version, so I can't run VSL2, the Windows Linux subsystem. So we're going to be developing Haskell on Windows, and we're going to be doing it, we're going to be compiling and running in PowerShell, which is not quite as nice as, you know, regular bash, but you know, we're going to make it work. Alright, so what we're going to do is we're going to check out day 13, like the latest one. We're going to see if that one actually, like, does it depend on day 11 or day 12? If it does not, then we're gonna run it. But if it does, then we're gonna just start off a day, you know, 11 or 12. And okay, sweet. So it doesn't. All right, so we'll just jump into day 13 then, and then the plan is later to kind of catch up. We're gonna do a marathon or something like that, you know. 4 hours doing 11 and 12, and the 6 hours doing the current days. I don't know, maybe next weekend, we'll see. Let's see. Start with the problem. Advent of code. I think I'm not logged in here. So 14. Oh, okay. Why is the order is all weird? All right, we're not gonna stop because the order is weird. Let's see. Shuttle search. Alright. Your ferry can make it safely to a nearby port. Oh no. Wait. Did the plane crash? Oh shit. Spoiler alert. I think the plane crashed. I mean, we don't know. Damn. Okay. Okay. Book another ship? Or did it like... Did the plane like land on a different airport or something? I don't know. All right, we're gonna be finding out, but you know, to me this is crazy. All right. Also, guys and gals, let me know on chat, like, if the internet is not, if there's something wrong with the setup, because I spent, you know, 10 days fine-tuning the other one, and now starting all over. Wait, I have one more light. Better? Doesn't change anything? I don't think so. But the setup looks good. This is a mic. This is a Rode Video Mic NTG. And you can connect it through USB to the... So I don't have a sound card. I don't have that fancy mic. I don't have the fancy headphones. But, you know, I think if it looks fine to you all, then that's all that matters, right? Let's see. Okay, shuttle bus service is available to bring you from the seaport to the airport. Each bus has an ID number that also indicates how often the bus leaves for the airport. Bus schedule shall be defined based on a timestamp that measures the number of minutes since some fixed reference point in the past. At timestamp 0, every bus simultaneously departed from the seaport. After that, each bus travels to the airport, then various other locations, and finally returns to the seaport. Okay? The time this loop takes for a particular bus is also its ID number. The bus with ID 5 departs from the seaport time spent 0, 5, 10, 15, and so on. 11. Okay, so I think we're going to be doing some modulus probably. Okay, if you are there when the bus departs, you can ride that bus to the airport. Wow. It's a lot of input. Okay, we're going to have to write a parser. And I hope we can use parsec or something. Let's see. I mean, okay, but it's not gonna be crazy much input, right? Let's see. 2 lines. The first line is your estimate of the earliest timestamp you could depart on a bus. Second line lists the bus IDs that are... Wait, so... Okay, your note consists of 2 lines. Oh, okay, we don't have to parse this input. This is the input. Alright, I see. First line is your estimate of the earliest timestamp you could depart on a bus. Second line lists the bus IDs that are in service according to the shuttle entries. Shuttle company. Entries that show X must be out of service, so you decide to ignore them. To save time once you arrive, your goal is to figure out the earliest bus you can take to the airport. There will be exactly 1 such bus. Okay. So we start at 9:39. Are we just gonna be figuring out like what the... Yeah. Also, like you all are like, the chat is now on like a tiny screen, or tiny. It's on my laptop screen, and then I have a big screen over here. So I can't see the chat as well. So speak up, use caps, and I can definitely see it. No, I'm kidding. I'll just make this thing bigger here. Wait, hold on. Screen is so small, I have to use all my hard-earned CSGO. CSGO? I never played CSGO. My hard-earned CS 1.3 skills to catch that exact pixel where I have to grab it. Caps lock is cruise control for cool. This guy reads bash.org, right? Sorry, I'm drinking Skyr. It is an Icelandic drink. Oh, and also my camera doesn't focus now because it's too focused on me. This is the shizzle. Let me jump out. I'm gonna grab my coffee. I mean, I just turned coffee into code, you know? Since I'm no longer at home, I don't have the Moomin cups, but I do have... Oh my god. Star Wars cups. Wow. What an epic cup, Maddie. Yeah, I'm at my dad's place. He's lent me his place for the duration of my quarantine, actually. It's pretty nice. One last thing. Rats swore. Yeah, I mirrored the camera because I'm looking at you and then I'm looking at the stream, and then it's so weird to see me non-mirrored. So if you meet me on the street, my hair will look like this. Just so you know. Alright, one last thing I want to point out before I start. Look at this t-shirt. What is this t-shirt? It's a woolen t-shirt, hand knit by my grandma. Yeah, it's the most Icelandic you can get in a t-shirt, a hand knitted woolen t-shirt. And you know, I just gotta represent grandma on stream, you know. Anyway, we have the following notes: 7, 13, 59, 31, 19. The earliest bus you can take to the airport. Earliest bus you can take to the airport. Okay, so we have these, and then I think what we're going to do is that we're going to take this number, we're going to apply modulus to it of all of these, and then that's going to be our answer. We're going to take the modulus, and then we're going to sort by the modules. Let's see. Which is the idea? If the earliest person you can take the input multiplied by the number of minutes you'll need to wait for that bus. Let's take the input. Let's go. And yeah, like I said, it's gonna be crazy. We're running Windows PowerShell. When I become famous, I'm already famous. I haven't told you guys. I got recognized at the airport from the stream. That means I'm famous, right? Yeah. No, that was like a very big badge of. I'm like, wow. And I was wearing like a mask and a visor and everything, right? This must be what Justin Bieber feels like, you know? Nah, I'm kidding. I'm kidding. Of course, you learned Haskell on Windows. Yeah. So, it works. It works pretty good on Windows, except if you're writing like a plugin that's fiddling with the type system. I was doing that. And sometimes it would just randomly crash with some crazy memory exception stuff. Yeah, that was crazy stuff. And the problem with Windows, with running Haskell on Windows, it's not so much the Windows part, it's more that... Wow. That is brave. That is so brave. Yeah, I'm using like the hard, like I just installed. I don't know how I installed it. I don't remember. I just remember that I did it to get the IDE working. And then on my other main laptop, you know, I did this in like March, right? And then I haven't used this laptop since March because I've just been home. I've had access to my main machine. And around that time, VSL2 came out, and just running Haskell on that is so good. That's just, it's the best programming environment, okay? Having VS Code on Windows, SSHing, or like it's connecting directly to the Linux machine, ugh. But I'm not allowed to upgrade. Let's say, make dir day 13, see? This is the cool thing about the PowerShell I'm using. PowerShell... It's... oh shit, yeah, in Windows they do like this. Anyway, this is like... What is this PowerShell? It is PowerShell 6. And the nice thing is that like a lot of these make dir and copy and move and all that stuff, they've like defined that as synonyms. Because, you know, you don't make, like, you write some PowerShell thing that says make dir. And, you know, PowerShell, you know, it's good. It's like an object-oriented command line scripting language. So there's a lot of cool stuff you can do with it. But, you know, I've just spent, you know, 8 years studying the power of bash, right? And not just bash, but, you know, all the new GNU utilities, right? I mean, because I'm using Linux, or as I like to call it, GNU/Linux. And you know all those utilities, and you're kind of crippled by not having those. So they kind of define synonyms for everything. So I can write ls, right, which is a new Linux utility, and it does what's the dir.exe command. Oh wait, it's dir, like, yeah, so you don't have to, it's easier to swap around. So I recommend it as a development environment. Alright, let's see into day 13. Let's see if touch is defined. Ugh, see? But some of the commands are not defined, so yeah. Oh no. New file. Day 13.hs. Okay, we're going to say test input. I'm doing the dash now. I used to do camel case. Now I'm doing the dash. You gotta mix it up, you know? It's the little things. We got the test input. Now, let's say module main where... Wow, you see the lag? Get input, it's going to take a file path, and it's going to take a list of string. Get input equals lines.read. We're gonna fmap. This needs to be IO fmap lines.read file. Main IO main equals. Oh, thanks for the follow. Horrible cow. Yeah, you're right, Kronko. But yeah, that's I think like that was the first stream or something. Oh yeah, wow, thanks for the follow. That was the first stream I did. I was like doing fmap over the input, and I was like, what is going wrong? And I was doing the right thing. I had forgotten to say IO string. Let's see here. We're gonna pipe it into print. And are you ready for this? GHC day 13. We can't do this because this is PowerShell. We have to do semicolon. Wow, we're getting so many followers. Thank you all for the follows. I really appreciate them. Okay, so we do this and see. Okay, so this is gonna compile and it's linking day13.exe. That's so good, right? Wow, so many new followers. I thought I only had like a very limited watch space, but it's a lot of new people, which is nice. Thank you all. So we compile it, and then we do measure command, and we have to do like this. We have to do expression, and then like this, and then we say day 13. Yeah, we need more Haskell streamers, right? They're all doing something different. Can you even see this? No, my keyboard is over it, right? I'll run it. Let me see. Let me split this. See this? Measure command expression day 13exe. Okay, this will run it and measure the runtime, but it will also pipe it to out default. You know, so instead of just writing time run the executable, I have to do all this. But you know, it's something. Oh shit. Yeah, okay, this didn't work. I have to do /. Okay. Now you can see that it compiled, but like the first time it runs super slow. So it takes us 25 milliseconds to take in the thing and print it. Now, I have text.parsec. Sweet. Let me see. Do I have autoparsec? Need more data.atto. I want to use autoparsec. Autoparsec is what all cool Haskellers use. Apparently, it's like super fast, and it has decent error messages. Parsec is not as fast, but has better error messages. And then there's something called Byte Smash, which is like insanely fast, but it doesn't actually do like the error message. I don't know. I have never tried these, but the error messages aren't good enough. But it seems like we don't have autoparsec. So let's just use parsec. Alright, now we are trying to compile parsec. Parsec package. Mega parsec. Oh yeah, that is also. So you have parsec, then you have mega parsec. But yeah, there's a lot of cool people in the Haskell community. That's what I like about it. They're all super nice. But none of them are streaming. Can you imagine if Simon Peyton Jones just started streaming live Haskell development? I would watch that. Okay, let's import data.text.parsec.bytestring and let's go. So we're looking at parsec. Some people have been looking at their personal stats in Advent of Code. And I think I have those. Yeah, stats. Where is the personal stats? Does anyone know? Let me see. 1, Because like someone was looking at like how fast they did stuff, and I mean that's cool. Yeah, donated money, but it's not about doing it fast, but it's about having fun, right? Oh, leaderboard, personal stats, right? And apparently it starts counting once you open it. So I started at 12, no, 13, what? Okay, so I have 0 score because I'm not competing, right? I started way later. I don't see, I thought like you could see, oh, I think this is like from when it was released. Yeah. Okay, yeah. That makes sense, right? And we start at 5 UTC, right? So, anyway, let's look at Parsec. Not that. Let's see. Looking at Parsec, we are going to take text.parsec by byte string, and we're going to say parse from file, and then we just give it a file path, and it returns an IO parse error or A. So, what do we want? Yeah, so we are going to say get input is not going to be fmap lines. It's actually going to be parse from file, and then here we say parse input, and then it's going to take in the file path. And what are we trying to get? We are trying to get, so it's going to be a parser. So we're going to write the parse input is going to return us, it's going to return an integer, which is going to be the ID, and it's going to return us a list of maybe ints. And we're going to say x is nothing, right? Parser input. Okay, this is going to be a parser. Parser input equals Okay, now we're writing a parser. This is what Haskell is good at, especially parsing combinators. It's cool. Let's see. So we're parsing byte strings, and we're gonna write a parser. This is the Harris Heller Lo-Fi Christmas playlist, by the way. So it's got a lot of Christmas stuff in it. So let's see. String. String is not what we want. We want char because it's going to give us. It's gonna give us a string. So we're going to say first. Okay, so do. So first line is going to be, we're going to parse. So we are going to parse, we're going to parse, we're going to say take while one, I think that's what we do. Delicious skier drink. Yes, Timmy. I'm back home now. I can have access to infinite skier. That moment when the skier hits. Good stuff. Let me see. Theories of the prim take while parsec take while one. Apparently take while one is like that is an auto parsec, but they're apparently super fast if you just take while one. And let's see. Okay, we're going to import. So that's what you're supposed to do. You're supposed to import text.parsec.char and then import text.parsec.prim. And so here we are going to parse digits. So let's see. So we're gonna parse digits until we don't get more digits, right? And then And then we're going to let me see. So this is, yeah, this is gonna be okay. So end of line, yes. Letter digit, text digit, octet digit, char. So we're gonna, let me see. What if I do just yeah. Parse to satisfy F for any character which, yeah, okay. Let me see, because I've never used parsec. Actually, I always, so tokens. Yes. So let's see. Many one digit. Do digs equals many one digit. So here, and then we have to define this crazy function. Yeah, it's overkill, but it's included by default. Yeah, I mean you're not wrong. But I think I want to see what happens. Okay. So we're gonna parse the digits, many one digits. So we're gonna say import data.char, and what you have to do is you have to. So here we're gonna write a function that says, you know, string to int. And that is going to be taking a string and it's going to return an int. And so string to int equals this crazy function. So you take fold L. So you start with 0, and then you say you take in the digit, and you take in the x, right? What is the, like I've said even earlier, what is the type of fold L again? I always forget. I mean, yeah, we could use read maybe, but that's not cool, right? Yeah, B, so BAB. So it's gonna be current X and then D, and then we're gonna say 10 times X plus 2 into digit, no, digit to int of D. You see how it works? This like takes the number, and then every time you add something new, it multiplies the previous one by 10 and then adds it. It's this is taken from I think the read implementation or something like that. But it's written by Eric Meyer, this way of doing it. But it works. So what if we just say here, return string to int of digs, comma, and then just an empty list? What does this then show us? Maybe int. And why can't I print this? Because, oh, get input, right? Get data? Data? No. What is it? Right, so this is gonna be an either. Okay, let's see here. Yeah, this is gonna be an either parse error or what? It's complaining Let's see. What? Either parse error A, right? Parse. Oh, right. Yeah, either parse error, maybe, but this is not in scope. What? Where is parser error defined? Import hiding. No, I mean, I'm importing everything. But it's just this parse error isn't in scope. Parse error. Text.parsec.error. Okay, yeah, I think I just, because I didn't import text.parsec, I just imported like everything. And okay, and I don't need this prim thing. Okay. Nice. Let's print it. I think it's gonna give us a parse error because... yeah, I could have used holes. But like the holes tell us what we should put there, but they don't tell us like what we can import. I think it will give us a parse error because like we didn't parse the entire input, and we'll say like incomplete input. No, see? We parsed it. Okay, now the rest we are going to do so timetable is going to be sep by 1 parse tt. Okay, and then we're going to say what does sep by 1 do? Sep by 1 takes a parser. Okay, yeah. So sep by 1, this is gonna be here a char, comma, and this is gonna be option maybe of let's say here, let's see, parse number is just gonna be, that's going to be what is it? It's gonna be string to int over many one digit. And this is not fine because ambiguous type variables. So parse number is going to be a parser of a or ints. Okay, so this is going to be parse option maybe. So many one so digs. So we're going to say here id is a parse number. Then we're going to say skip we're going to say skip many one. No, yeah, skip many one, and then it's gonna be sep is second. Oh, yeah. I mean, I think I got it working, right? Let's go skip many one, and we're gonna use these. End of line. End of line. So we skip the line, and then we separate the option maybe of parse number. So if it can't parse a number, it's just gonna give us a maybe. So time. So here, and then we're gonna say this is gonna be id, comma, timetable. And this is not okay because sep by 1 returns a maybe. Option maybe. Okay, yeah, sorry. That is true. Sep is second. Listen to chat. Let's see. This is a bit slower because this machine isn't quite as powerful, and it doesn't have a graphics card, so like the rendering of the stream taking a lot of the CPU. Okay, just 7, just 13, come on, nothing. It should be doing more, right? 7, 13, and then it says nothing, and then it stops after it fails once? Huh. That's not what we wanted, right? Okay, then let's just do it differently, right? So let's just say choice. So the choice is gonna be so it's going to be set by, okay, and then we're gonna have the char, but this not gonna be parse number, it's going to be a choice between just f mapped over parse number, or it's going to be, you know, it's going to be char x into pure nothing. And it says I don't need these parentheses. I don't like that I had to do this though. I thought set by 1 would not fail. Anyway, now we have the correct, right? Alright, now we got the input. Let's... No? No? Doesn't work. What is the type of that? Well, how do you pronounce that? So I think it doesn't work. Let's see. I think, yeah, so it takes an A. No, I think it doesn't work. I mean, it should work though. And it says not in scope. I think that should be in scope, right? It's in control.monad, right? Yeah, I need to separate again like this. What? Oh yeah, this is the wrong symbol. It's not exported. Why are you telling me that it's... Let's see, now we have this operation and it complains. Do I need to say nothing before? What if I apply it here? I don't think it works. So it takes in a functor. So I think the issue is that like this char thing happens in the parsec monad, right? And not in the maybe monad. Let's see. This is the same as doing BS and then pure A. But, so A, BS, yeah. But it's complaining that this whole thing... Okay, this is a redundant bracket. Couldn't pass... I think the issue is, see, it's trying to return a maybe, but it's actually in the monad. The thing you're putting goes first, okay. Let's see. Oh, that works. Cool. See, we have some Haskell experts in chat. It's all about knowing the symbols. Haskell is like math, right? It's just a game of symbols. Yeah, that it looks better, right? Just nothing. Let's highlight the symmetry. Wow. That is nice, right? Good stuff. Okay. Now we have the input. I think, yeah, complete overkill, but you know, that's what we're here for. Okay, let's see. Let's see here. Wait, G. Oh, G. So I'm using Vim key binding, so I always press big G to go to the end, small G to go to the start. Good stuff. Okay, solution 1. It's going to take an int and a list of maybes. Okay, and we are going to return an int. Solution 1. Okay, let's see here. We're just gonna return. We're not gonna return anything. So solution 1. Okay. So where? So let's get all the ints. Times is gonna be cat maybe of. So this is gonna take, you know, our ID. Let's say shuttle ID. Sid is better, and then times, and it's gonna be times maybe, and then it's gonna be times maybe, and we have to import data maybe cat maybes. Okay, and then we have all the ints. Now we have like a list of ints. Now I want to do what I want to do is I want to take the, so I have that times, I want to take so we're gonna say next departure is going to be a map ID SID, and this is gonna be, oops, this is gonna be mod over times, and then I'm going to sort that, and then I need data list. We're gonna sort that, and we are going to take maximum. Now we're gonna take the minimum of next departure. We don't have to sort it, but I want to see here, so I'm gonna say trace show id. I don't actually need this one. We don't need data.list anymore. Import debug.trace. Let's see solution 1. And this doesn't work because we return either parse error. So we're gonna say fb do parse fp case parse of, if it's a left parse error, we're just gonna say error. If it's a p, we're gonna say error p show. Otherwise we're just gonna say return res. What is Case parse of, yeah, if it's left, then we're gonna return error. Let's see here. Now, okay, yeah, and it's a problem here is that I want to return this. Like this. Let's see. Debug.trace. Yeah, exactly. Okay, 135498. Okay. So it says 1. So let's see. What is a 939 divided by 7? It's 134. So 134 times 7. Yeah, I'm using Google as a calculator. I mean, they have a lot of good people working there, right? So you should trust their results, right? So yeah, 134 times 7 is 938, and 938 plus 1 is indeed 939. So this seems legit. Let's see. The 7. So okay. The earliest bus you can take is bus ID 59. It doesn't depart until it starts at 9:44. What? Why? Okay. Let's see here. Trace show ID. I think I'm doing something wrong, right? I'm not supposed to take the max, I'm supposed to take the minimum, maybe? So for 59, it's returning the max. It's returning, that's the maximum. The earliest bus you could take is bus ID 59. Do I need to flip around the modulus? Oh, right. So the problem is, okay. Bus 7 departs at 9:38. And that just left 1 minute ago, right? Now bus 59, 9:44. Yes. Let me see. I think I might be doing the modulus wrong. Let's see. Like this. What do we get then? Yeah. No, that's of course, yeah. This is wrong. Okay. Okay, so I also need to include the IDs. Okay, let's see. So if I say here div, let's see, div. Because like this is some modulus problem, right? But I think I'm thinking something wrong here. Okay, we map this with the times, so we do the division. And then we're gonna say we'll go zip with, wait. Next departure time. So we take these and we do zip with, we're gonna multiply. And then we're gonna say here times. And it doesn't like this next departure time because the type is wrong. Yeah. Yeah, it means that the bus left 1 minute ago. Oh, yeah, okay, yeah. So, that is true. This is, so here, so this is how long ago they left, right? So we're gonna do mod, and then we're gonna do minus. And we are going to say, oops. So, yeah, so this is how long until the next bus. So, yeah, so it's the difference. So now we're going to say so okay, so we found the next departure time minus we found the right one. Now we're gonna see like which one is it, right? So let's see. So here we're gonna map over times. We're gonna say, you know, we're gonna say x. We're gonna say x comma sid, so x minus sid mod x. Isn't there, can't I like just take the negative modulus? Isn't that a thing? You know, I can just do sid mod period negate. I think I can do that. Let's see. Let's remove this here. This is what I should be able to do, right? Yeah, exactly. So we take the negative modulus, then we get what we were thinking, right? So, and now we take the maximum negative modulus. It doesn't work? I mean, we're getting the -5 here, where we were getting 5 earlier. So we just negate twice. Bloop, bloop, bleep, bloop. Okay. Same as doing the minus thing. That's what I was thinking, like, there's a trick with moduluses, but like negative moduluses are a bit weird. But they weren't. Let's see, x over to x comma. No, now we're gonna say, wait, we have to know the time, right? So we have to say, what's the idea of the earliest bus you can take the airport multiplied by the number of minutes you'll need to wait for that bus. Okay, so this is gonna be, we're gonna take the negate here twice. Okay, now let's just say, let's do a funny thing. Minimum by, and then we do this function. And times, this is from data.list. allows us to specify minimum by. Alright, it takes an ordering. Minimum by. Do I have to do like on here? Something like that. This is from data.function, so I could. So I've done this like sort on data.function on. So on takes in. I think this is, yeah, compare on. That is correct. Compare. Oops. On this function. Oh yeah, now we so we say oops. Next departure time. So this is gonna give us 59. Yeah, 59. Next departure time times how much do I have to wait? That is going to be next departure time times, so this is gonna be the SID times next departure time times the how long do I have to wait. That is SID minus SID oops oh my god, keep pressing the wrong button here. Like this, right? Yeah, SID div next departure time I'm doing something wrong. This is gonna be 59. How long do I have to wait? That is going to be... I have to wait next departure time minus SID plus the SID, and then we take the negative modulus mod negate next departure time. Dim 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 dim. 3186. No, that's not correct. What is this gonna be? Trace show ID. This is -5. And oh, okay. I should just negate this, right? This should be correct. Ding 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 ding. 295. That's the one, yeah. Don't need here. Don't need here. Always nice to have HLint telling you where you need parentheses or something. Double negate does the same thing. Yes. You gotta negate that stuff. Okay. Works for our test input. Do. Let's see. How does it do on the input? I think this one is gonna be fine. Let's see. Input. Get the puzzle input. Oh wow, so many X's. Good thing we have a good parser, huh? Am I wrong? Compile it and linking, and then we run it again. 27 milliseconds. 4315. Let's see. Is it gonna be correct? Oh no. Whoop whoop! We got the first one! Only took us an hour, but we did write a parser. And we did do a bunch of double negations, right? Talking about my t-shirt and stuff. Anyway, let's continue. Part 2 is gonna be harder. It's usually like that. Not always. So, 1 gold coin for anyone that can find the earliest time, such as the first bus ID departs at that time, and each subsequent bus departs at a minute. For example, suppose you have the same list of bus IDs as above. An X in the schedule means that there are no constraint on what bus IDs must depart at that time. The earliest timestamp called T such that bus ID 7 departs at time T, bus 13 types at okay. This is like gonna be some Chinese remainder theorem. Oh shit. Oh, it's gonna be some modulus stuff. I remember I did so much modulus stuff. Back in the day. We're gonna have to look up Chinese remainder theorem. That's how it's gonna be. Okay, so, bing, bing, bing. Okay, let's figure it out. Let's just start by looking at our input. No, this is day 10. Day 13. Let's start by looking at our input. Bring, bring, bring. But yeah. Does anyone doubt the benefit of a good education? Instead of iterating through all the things, we're like, Chinese remainder theorem. It's gonna take us as long to look up Chinese remainder theorem and learn it, but it's gonna give us an O of 1 answer. It's gonna be epic. So, here, I'm going to say... Okay, this is gonna be... I don't know. Undefined. I'm just gonna return as an int. But we're just gonna... Yeah, let's see. So times maybe, and then I'm gonna do sip 0 and so on with times maybe. So this is gonna give us int comma blah blah blah. Integer. Yeah, that is true. It's gonna be an I'm gonna do int because advent of code usually works with int32. But okay, let's say integer. I mean, all the Chinese remainder theorem stuff works with integer. Let's just say here times head fs dot of head of times, and I'm just gonna do it this way because I want to do trace show ID. So we sip with 0, and then we filter by isjust.fst. Bam bam bam. Why is this wrong now? It's because this is an int. No, this will return... Could match query type int. FST. And then it's complaining that... Oh, this is supposed to be... from just a second, right? Read the bottom of the form. Oh, okay. Jeez. This is bigger than... Yeah, let's do integers. Let's see. Filter is just... No, this is gonna be second. And this is gonna be... isn't it? Couldn't match expected type. No. I just want to see, you know, if we did the list correct. And what is it complaining about now? Line 36? Oh. No longer relevant. We don't care about this anymore. No, let's just run it. We're gonna be getting a lot of numbers out. Oh no, not a lot of numbers, but let's see. Ding, 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 ding. Your mic is fluffy. Yeah, this is like a for extreme wind. Like I have another one that is just like more regular mic, but this is for extreme wind. And if you know anything about Iceland, it's good to have a windshield. All right, 0, 1, 4, 6, 7. Yes. Okay. Now we want to find x such that so x is going to be a modulo of the first number. So it's going to be a modulo of 7, and it's going to be the second one. It has to be modulo 1 of 13. As a modulo 4 of 59, modulo 6 of 31, modulo 7 of 19. Now, Chinese remainder theorem. Do 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 do. Okay, so we have the times. Here we're gonna say x, we're gonna say x comma just x, just y to x comma y. No, because we don't want to adjust, we don't want to adjust stuff. If the modulo was 1, then the bus left 1 minute ago. Yeah, but we want it to be 0, right? Oh, -1. Yeah, okay, I think that's correct. So let's negate. That was what we learned earlier, right? We wanted to find the -1, right? All right, so 0. So this is gonna be what was it? -7, -13, -59. No, wait. We're not negating that. We're negating this x here. When did the music stop? I forgot to press replay. I'm gonna put my favorite one on this. I like this one. It's called Ice Cream in Winter. It's good stuff. So -1, -4, -6, -7. Now, Chinese remainder theorem. Yeah. So we have A1 equals mod N1, right? So this is exactly what we're trying to solve, right? x should be 0 modulus n1, and it should be, you know, minus 1 modulus 13. So that is the n1 and I are pairwise coprime. You know, I think we can assume that. Oh, where's the post? Can you show it to us? Can you like link it? We can just look at that instead of the Wikipedia article, right? Or does it like include a solution? If it includes a solution, we don't want it. Let's see. I'm clicking it. Clicking the link. Chrono Kirby. Oh no, it came up in the Chinese remainder. Yeah. I'll look at this a bit later. Okay, it's just CRT. Yeah. So this is what we were talking about. We want exactly this. Dun, dun, dun. I like this cat. Bezewolt's algorithm. All right. So we have to do GCD, Euclid, extending, Bezu, Chinese remainder theorem, 2 equations. Okay, we're doing all of this stuff. I mean, this is essentially what we're doing. Right? And put that in here. Wait, no, why can't I? Oh, this is not. I have this issue where like I'm using the beta version of Chrome, but then the links open in. Yeah, exactly. If these aren't prime numbers, they're gonna be not co-prime, right? So exactly, we have Bezowites. So, ding ding ding. Let me see. Ding 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 ding. A solution of the system of congruences is sum from I up to k, ai1, min, ni1. Ding, 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 ding. Okay, there exist integers. So what is the min1 here? Let ni be n over ni. So the big N here is not just the big N. Is that the number? That's the number of n, right? Bing, 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 bing. Okay, so I wanna find this here. So the result is gonna be the sum of so the result here sum of, what do they call this? Well, thanks Danny Root. Oh, the product of all the moduluses you're taking. Okay, yeah. Oh, okay, yeah, so let's see. Because let's see. Big N is gonna be the product of map second of times. So what is big N? I think I might have to convert these to integers actually. So int to integer. To integer. Easy enough. well, let's just map to integer here. So what's the big N here? Just want to see. It's gonna be a big number, right? We're multiplying so many numbers together. Oh, that's not the biggest number actually. Okay, so we have the big N. Okay, and then we have to. So like, I like this post, but it's like it's too close to the solution. Probably too close to the solution, like, because I could just copy the thing you wrote and solve, and it would just essentially be solved, right? But I wanna try it out a bit more. So, okay, so extended Euclidean algorithm. Okay, so we have to. So this is the x here. Is going to be the sum of I'm going to have so it's going to be SIP with 3, right? Yeah, so it's going to have the sum of SIP with 3 function of the A and the N and the wait, like M first, right? Sum of A Y M I N I. Okay. SIP with M and then N of A times M times N. This is not supposed to be like this. Sum of the SIP with takes in 3 lists. Map the AIs are going to be, that's the numbers here, right? AI mod. It's going to be this map of second of times, I think. And then it's going to be M's and N's. MS, NS. Map of second of times, right? Let's see. Because I'm getting a bit confused here, right? So so we're trying to find the X. Exactly. So X should be so it should be the. So what is the A1? That's so the 7. Yeah, so 0 mod 7 should be N1, right? And then so yeah, the second one should be -1 mod 13. So the N's are going to be map first. The N's are going to be map first, the map second of times. The A's are going to be map first of times. So let's say here it's going to be. So we found all the A's. We know the A's and the NS, and now we have to compute the M's. So this reducing to solving the initial problem K equations to a similar problem with K minus 1 equations. Yeah. That's the best weight. The Bezois. I don't know how to pronounce it. Bezut. Identity applies, and so we have to have. So we're figuring out. So So it consists integers mi and ni such that okay, so that we can figure out m1 and m2. We can compute them by the extended Euclidean algorithm. Let's see. So we have n1, so that's going to be ni, and the small ni. Okay, so let's see. So the ms, so it's going to be compute ms, and this is going to take in an ni. So the big ni, where big ni, that's going to be big N divided by ni. Oh, I think I need to do, it's going to be div. So we have big ni, and then we have ni, and then we have to find the m1 and m2. So the big mi, so this is going to be big mi, and these are going to be map compute ms to the ns, right? Big mi is going to be undefined. So we have ni here. Now we only need to find these small ni, yeah, okay. So in addition to the greatest, the other, yeah, which are integers x and y such that, okay, so ax plus by, so we find x and y, so we compute the GCD. So okay, so big mi, so I have to say, because I can't say mi, I think that's gonna be like, it's gonna think it's a data constructor. All right, big mi equals a GCD of GCD ni big ni, right? But no, we should have the GCD should be 1, right? Bezout's identity algorithm. Let's see. Dun 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 dun. Let's see, Bezout's identity algorithm. Let's see, case of 2 moduli, then Bezout's identity. Yeah, let's just look at that. Bezout's identity is the following. Let A be, there exists with the greatest common divisor exists integer x and y such that ax plus by is d. Okay, we just need to figure this out. Let's see. If A and B are not both 0 and one pair of Bezout's coefficient of a compute all pairs, okay. This is Bit rough, right? Let's see, so we want this to be 1. So we have to find out such that the greatest common divisor is let's see. Okay, let's see here. Let's find out Bezout's identity algorithm applied to the ones we know: big Ni and Ni. Okay, where? Okay, so and Bezout's identity algorithm is going to take an integer and another integer, and it's going to return a pair of integers. Bezout's identity algorithm. Thanks for the follow, Leibniz. Disciple. I bet the Leibniz disciple likes monads, huh? Am I wrong? If A and B are not both 0 and one pair of Bezout's coefficients has been computed, e.g. using the x, then all pairs can be presented in the form x minus... What is... This is a plus. But it, like... I don't know if you guys see this, but on my screen, like, this plus isn't... It, like, it didn't render the... So let's see, so we are trying to compute x and y, so this is gonna be a and b. Okay, so it says it might be computed using the extended Euclidean algorithm. I am not... Okay, modular integers. One should remark the Bezout of coefficient is not needed and thus does not need to be computed. That's true. We only need the big MI, right? Let's see. Does T, or more exactly, the remainder of division of T by N is a multiplicative inverse of A modulo. Oof. I have this book, but it's in Sweden. Let's see. So, to adapt, so this, we return T. Okay, let's see. While new R is not equal to quotient. Okay, let's just translate this algorithm into Haskell. Chrono Kirby. I think you use the integer case here, not the modular case. But it's only talking about integers, right? Okay, let's see. The computation stops. Okay. Oof. It'd be this is the extended one, right? Yeah. Okay, that's true. I am feeling a bit woozy. It's okay. Let's see. We're trying to implement this Bezoos algorithm. We have a solution already because Chrono Kirby has it in his blog post, but we don't want to use that directly. We want to work for this, right? Okay. Let's see. Now we just need to figure out. Oh, here this shouldn't be integral. It should be integer. So what are we doing so far? We're trying to find x comma y such that ax plus by equals 1. That's correct, right? Yeah. Okay, so this is gonna be some Euclidean stuff. Okay, it's easy to check whether a value, yeah. Yeah, okay. Okay. This implies that the solution brings to the management protection by testing the values modulo n scope to. Okay, so the product of moduli. This method works well for handwritten computation with the product moduli or something. Wait, let's see. What did we get here? What was the big N? Let's run it again. Oops. Get data. It's gonna be undefined. Let's run it and compile. I just want to see what the the product of the moduli is for the input. Let's see, because it's gonna be a huge number, right? Yeah, this is a very big number. If I'm gonna get some water. Hold on for a second. Important to stay hydrated, right? Okay, now, so we're looking at Bezoos in the identity. So, structure solutions, example proof, generalization, history. We're just trying to figure out okay, if G is the greatest common divisor for two polynomials A, B, not plus 0, there are two polynomials U, V such that A, U plus B, V equals G. This results in the case of polynomials is that there's okay. And so the output computes G. But if we want to fix G, so that G is 1. Extended Euclidean algorithm. That's what we were looking at earlier, right? Now, in computes, in addition to the greatest common divisors GCD of integers a and b, also the coefficients of bezoars in 10 to g, which are the integers x and y, such that. So let's just see here. Hugo, is there an implementation of GCD? Yes. Nice. GCD. This laptop is so slow. I mean, it's not slow, it's just doing so much, right? Okay, but it's in the prelude. What? Said it was in the prelude, right? GCI. So this returns the greatest common divisor of A and B. So let's write here. Let's just see, you know, what is GCD of big and I and I. So we're gonna see what this is, and then the compute MS, and then we're gonna say head of MS. Trace show ID of MS. Let's see. Yeah, it doesn't, but all of them return 1. Nice. So, yeah, so that is exactly, okay, that's what I was trying to figure out. I was like wondering, oh shit, do I have to figure out to change it such that the GCD is 1? But I don't have to change that, right? Because we have defined big NI as yeah. So we multiplied everything and then we divided by so the thing is, okay, because like big NI is a so big NI is equal to, you know, n1 times n2 times nk, right? And these are all coprime. So, you know, big NI, right? Okay, this is the thing. This is a trick. Big NI divided by NI, like NI will not be a factor in big NI because all of these n's are coprime. So like this will be so big NI, you know, so the greatest common divisor here, so NI is not going to be a factor in big NI essentially. So we have this GCD a comma b is 1, so we just have to find the x and y, right? And then we can use the greatest this GCD, okay? Let's see here. Finally notice, okay, and then compute y at the end. Saving memory, accelerated variables, following algorithm, uses parallel assignments, blah blah blah. Okay. So this is equivalent to similarly this will lead to following the codians. Okay, so this is this code, but then it's saying that there's something else also. Why is there why are there why are there two codes here? Proof section. Yeah. So what I'm just wondering here is why are there two codes? One can solve y for a given a b x gcd a b. Thus an optimization above the curves is only compute the sk sequences. Okay. So let's define this in Haskell. Okay. Oops. The pseudocode, okay, gc so extended gcd. We're gonna write it like this. It's gonna take in an integer and an integer, and we're not gonna. Okay, we're gonna just return a pair of integers. Let's say integer and extended gcd ab equals extended gcd prime. So of 0, and then old s is gonna be 1, and then this is gonna be r, b, and a. Where extended gcd prime of s, old s, r and old r equals, okay, so now we're gonna say while r is not equal to 0, do. Okay, so we're just gonna say here, let's see, so this is gonna be the same, extended gcd prime s, old s 0, old r equals, this is the base case, if b equals 0, if b is not equal to 0, okay, so case, so if b equals 0, so the GCD of A and B will be 1, so we don't care about that. Well, let's just return all of them, right? If b equals 0, then it's going to be old s, comma 0, comma old r. Else it's gonna be old. Right, now let's not do it like this, because it's always going to be old s, right? What do I think programming will be like on yeah, it's going to be awkward. There are some very good scientists working on very very good programming languages for actually, what do I try for quantum computers, but we're not quite there yet. But I think that's how we're gonna do it. Where besu equals, we're gonna have the good. Yeah, that's. Yeah, isn't it like probabilistic programming in some sense? But it's going to be hard. Quotient. The quotient is just div, right? What? Yeah, I think that's just div, no? Then quotient, let's just write it directly. Quotient times R. What the quotient of old R minus old S times A, and B else 0. And here the quotient is just div, right? I think it's just gonna be div. Okay, and extended, so if it's 0, then we don't care about the S. Otherwise, we do a loop. S old SR. Okay, so the quotient is exactly where Q equals old R div R. What is this is equal to, this is gonna be a loop. Extended GHC S prime old, so it's gonna be S is gonna be this, and R prime, this is gonna be R prime and old, and this is gonna be R again. Q is gonna be old R div R, and we don't have to do this, so we just have to say R prime is equal to old R minus Q times R, and S prime equals it's gonna be old S minus Q times S, right? Once, yeah, but so the thing is, like, I did my maths, right? But I did it all in Icelandic. I'm always like, what is quotient and divisor? I should really relearn all of math in English. But yeah. Okay, so old S, old R minus old S times A, L0. Okay, now let's see what this is, right? Bling, 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 bling. This is gonna be a big, well, let's see, what is it gonna be? It's gonna be old S B old R equals extended GCD of big NI and NI, right? So the bezo is never gonna be 1. The GCD, this old R will be 1, right? So we're gonna be looking at old S and bezoa T. Let's see. Trace show ID, and let's return. I think we returned the B. I just want to see like the trace of what it. So okay. What? Oh, the B's are all 0. Gling gling. Da, 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 da. Yeah, so these B's are all gonna be 0. So I guess we are looking for this number here, -6. so these, I mean, and the old R's, they all turn out to be 1, right? That's exactly what we wanted. So we're only looking at the old S. Now, that is gonna be the big MI. Now we're only looking for the old S. Okay, yeah, this is, I think this is good. Bring, 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 ding, ding, ding. Okay, we're getting negative results. So the sum here is negative. Is the sum here 4? Yeah, that looks weird, right? So, let's see. We want to return this, right? Okay, you should be able to check that a times x plus b times y is equal to 1. Yes. Because this number for the test input is not at all. It's not at all, because this here, yeah, is not at all this, right? Okay, so we should, yeah, so it shouldn't be 0, right? Let's see, so this should be big Ni times yeah. So what are the S's and R's here? Statement, okay, the S and R, this is these, to compute the SK sequence, which yields the Bezo. Yeah, so we want the Bezo coefficient X. And then compute Y at the end. Let's see. I think we should write this code instead, because there's something wrong with the stuff. Let's see. R, S, and T. I'm a bit confused what the X, yeah, X, Y, G, C, D, A, B, yeah, exactly. So, so X, Y, the A, B, so it's A times old S, big N, plus Ni times B, and then we return old S. I think we should be returning the B, right? But it's always 0, so that doesn't work. I mean, yeah, this is just... So we get -1. Let's see. Something wrong here, right? Yeah, let's go to this one. There's something going on here that we're not quite getting. So this one seems good, right? Okay. So the extended AB, okay, so we initialize it by, this is going to be old R, and then it's going to be old SS, and then it's going to be old T, and then we are going to we're going to say, so the old R is going to be, so it's going to be R prime, S prime, T prime. So we're going to initialize this. So old R is going to be A and B. This is going to be old S is going to be 1, and S is going to be 0, and T is going to be 0 and 1. What is it complaining about here? Okay, extended G, so while R is equal to 0, so okay, if R is 0, old R, 0, old S, S, old T. Okay, so this should be old S, old T, and so the quotients by the GCD, the Bezois, so we're calculating the Bezois coefficients, right? So we want the, oh sorry about that, old S, old T, and then old R. We don't care about the S and T's. We don't care about this. Okay, now we are going to apply a T and T prime. Okay, so Q is old R divided by R, right? S, so yeah, we've already done the, so R is going to be old R minus Q times R prime. S prime is going to be old S minus Q times S, and T prime is going to be old T minus Q times T. Let's see here. Beep. Yeah, now it actually does something. A times B, A plus BY is equal to 1, which is exactly what we want. So we want to return the B here. Let's see. But now we get minus 43, 1140. Are we sure that we want this to be negative? Are we sure we want to be negating these x's? Let's see. Or we just get the same except negated. We want to be returning the EVs, right? Let's see. Two. This is not the right answer, right? We want 1, 10, 68, 781. Okay, so big NI times old S plus NI times B is equal to 1. And then we found X and Y such that let's see. Where we had it here, right? Okay. S and T. Do we want to return the S and T? Alright. Let's see, let's go back to the Chinese remainder theorem. Yeah. Let's see. Okay. Now let's go back here and let's see here. And there exists integers mi and ni such that mi ni plus mi ni is equal to 1. So this is big ni times old s. Oh. We want the big ni times big mi plus mi. So we want big ni here, and then we want mi here, and this should be 1. This is just going to be a irrefutable pattern, as it's called. And what is wrong here? Yeah, big mi. It's gonna be wrong? No, it should be right? So big Ni is equal to you want to return old S. What is old S here? We're trying to compute the MIs, right? And so this is always 1, so that is, you know, the result. We're getting the right result. Okay, so big Ni times big Mi. Am I doing this correctly? You're multiplying by small n instead of big N. Oh. Yes, that is correct. That is absolutely correct. So let's just say this is going to be sip with. It's going to be mn. So we're just going to be sipping with star, and then it's going to be mns. And compute mns. That is going to be. This is gonna be big Mi times big Ni. Let's see. Oh, we're still getting weird results. Normalize by taking the... Yeah, by taking the modulus. So you wanted me to do 1 modulo this? What is mod big N? Right. No. Still wrong. Maybe like this. Big Mi. Mod big N. I think. Yeah, okay. I see. So this is gonna be like this, and then... No. That's still not giving us the right example. For the test input. Okay, I'm gonna take a quick bathroom break actually. Yeah, I'm gonna run that check right after. Give me 3 minutes. Oops. Okay. Let's see. Let's just go over this. Just go over this a bit. So we have the extended GHC, right? So this finds a comma b comma r such that ax times b plus by. No, it finds x comma y for a comma b gives x comma y comma r such as ax plus by is equal to r. Okay, so then let's just check it out. Okay, let's just say case of okay, this is gonna be case of x comma y comma r a times x plus y times r b times y is equal to r res other goes to error invalid GCD, because I just want to be making sure that, because I don't think I think we did the extended GCD here correctly, but I don't think that's the issue. Okay, so so this extended GCD is correct. Okay, now so we erase this. Okay. I mean, you know, we kind of knew that already. Now let's look back at the Chinese remainder theorem. So let ni equals n over n prime be the product of all moduli but 1. As the ni are pairwise coprime, n and I y, the best way to understand it exists integers mi and me such that me plus me equals 1. Yes. Okay, so now let's find those. So we want A1 to be we want this to be 0 mod ni. We want this to be, so these are the A's, right? That's the first. So this is trace show. Let's see. This is trace show id. Okay, now we are going to be looking at the times. Let's see. I think those are correct, right? So this is RA and this is NI. Okay? These are the NIs. So the big NI, the big N is product of NS. All right. Yeah, okay. Then MINIs equals map. So this is going to take in an n and it's going to give us extended GCD of so the x going to be, so the big N, and this is going to be divided, oops, divided by N, and the other one is going to be N. And so the M and I's, so let a N, a big Ni equals this here in extended GCD big Ni N comma big Ni. Ding 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 ding. I'll map this over the ends. This is going to be giving us the big Ni. So these will give us the Ni, the big Mi and the small Ni's. So let's see here. Big Ni, a big. So it's going to be this. It's going to be giving us the Mi and the Ni and the R and big Ni comma N. So let's just return trace show ID me NIS 0. And there's like a parenthesis is missing here. Trace show. Let's just see what we're looking at. Big N. We're just getting a feel for what we're doing. It didn't work. This is the big N. And then this is one entry. Okay, so the N here is 7. Okay, and the M, the big okay. Okay, so these are all 1, so that's okay. So AI, MI, big NI. Let's see. Let's have this be A comma Ni, and this is going to be Ni, and it's going to be Ni. This is N. This is going to be times. We don't have the ends anymore. Okay, we need the ends. Okay, let's say let big Ni in. So an extended G is so it should be giving us. We're gonna have an irrefutable pattern. Alright, oh my god, I have a nice line keyboard, okay. Of a big Mi, comma, 1. Okay, I think we have to have a let in, and we should just have another let here, and then multiply times, and then this is going to be big Mi, comma, Mi, big Ni, As. So we I want to see here. Yes. So what I want to calculate here is, oh my god, I want to just calculate big Mi times big Ni plus Mi times Ni. Dun, 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 dun. There's something wrong in here. Okay, so right. So this should be big Mi, big Ni, As. Let's have all of this in a big tuple, and this is not very clear, is it? No, this is this one. So it starts like this. It's gonna be like this, and this is all gonna be one big tuple. And we're gonna say A. Not gonna be As. This is gonna be A times big Mi times big Ni. And this here is supposedly supposed to be the sum of the sipping. It's just gonna be the sum of the map second of a mini NIS. Incorrect indentation. If yeah, and then this is a function. Min MINIS. And where is it not in scope? In here. Okay, MINIS. Okay, and let's see. Okay, so this is the big MI and the small MI. This is a big N I and this is Ni, okay? And then this is the A. So And the result of multiplying this with this and this with this is indeed 1. And then this is 0. That is correct, right? This should be 0. Should it be 0 though? Yeah, I mean the A here is 0, so this should be 0. Now, okay, we have this 1 times this plus this amount times this is equal to 0, and the A is 1, so it should be 1 times big Ni times 1. Dun, 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 dun. What is this? Same here, but this is a minus, a negative number. Am I supposed to take just the absolute value of this? No, right? No, that's not correct. So we found this, right? AI MINI is equal to AI. Okay, let's see here. Dun, 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 dun. That's another sentence. Each of the A times big N should be modulo, should be A modulo. Yeah, exactly. Yes, so let's check that out. Okay, and now let's look at A big MI, this, all of this. Oh, come on, like this. This mod Ni. Okay, let's just make these into booleans. This is equal to 1, and this should be A. We have true, 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 true. So it passes the sanity checks. It won't be exactly A though, but it happens for us to be exactly A, right? Okay, so how do we make it normalize? Oh yeah, that is true. So how do we normalize the modulus? That's the question, right? So I do yeah, exactly. So I do modulus An I, right? No, that's not true either. No, yeah, this is just gonna be A, right? So we have to do mod big N. Oh, okay. Thanks for the subscription, Cersei Race. And Marty. I miss Marty. I am way too because it's just not working out, right? Because you know, if I do mod big N, I get this number, which isn't. It's not what we want, right? Blip, 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 blip. So we found an X. Maybe we're just like not finishing the thing, okay? So we found an X such that... Okay, let's see. We have this. Okay, these are the times. So I just want to check. Okay, let X, so X is going to be this here, right? The sum of the map of the mini NS, okay. And then XRes, let's see, map this, oh my god, why does this keep, I keep pressing the wrong button. Mod and so X modulus the number of map of the NS. XRes. Oh, so here it says 0467. It should be... Oh yeah, that is the A's, right? Let's see. So we have the number. Zero and then 1, 4, 6, 7. And we want the time where the bus leaves 1 minute from now. Okay, yeah, okay. So that was when we should negate this, right? But then we get non-exhaustive patterns here. So, and then, you know, when we get that, then we get that the extended GCD is not 1. This is Haskell, programming language Haskell. We're trying to solve day 13, and we have all these Chinese remainder theorems going on. You get to negate x. Yeah, but negating x is not gonna... I mean, so what I'm saying is, you know, we have... Okay, yeah. So we have these. Okay, let's negate x here, right? But, you know, then I get the wrong results. So it needs to, so 0 needs to return 1 minute from now, 4 minutes from now, 6 minutes from now, 7 minutes from now. Yeah, so now I've negated that, right? But it's still giving me... Is it wrong? Yeah, 4231122 is in fact not 1068781, right? Let's see. 7 departs plus 13, so this would be 0, 1, 4, 6, 7, okay? It is 0, 1, 4, 6, 7, so we have the times, right? Yeah, I mean... But the result is not correct, right? And we found an x such that... x mod 7 is 0, usually now, and then x mod 13 should be minus 1, okay? Okay, so let's see, so 0... What if I do here, instead of 2 integer y, I do 2 integer y minus x? Okay, all of this modulus mod begin. Nice. Okay, but we don't need this. It was giving us the same answer, right? All right, we finally got it. Oof. We got like a big negative number. Yeah, this is because, like, you know, we have the right approach, like the Chinese remainder theorem, but then it's just like you have to make it all, because, you know, modular arithmetic is not my forte. So yeah. Okay, so we're calculating this. I'm gonna do it like calculate this. Oof. Okay, so what mini ni's? Yeah, this is gonna be the sum. Sum mini nis mod big N. Yeah, I really should look up my Chinese remainder theorem again, right? Yeah. Okay, so let's see. We get the correct result. Now we don't need the ns, right? Oh yeah, we need a big N. Ding 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 ding. All right, let's apply it to the input. Let's see what happens. Big number. Will it work? All right. We did it. Oof. This is what happens if you fiddle around with the big modular theorem. You know, we could have used a Chrono Kirby's algorithm, but yeah. And this is correct, right? So this was just taken from Wikipedia, right? We just did the GCD. We even have some error assertion here, which you don't really need. But we did the solution. And you know, this is not a long solution, but you know, there's a lot of tricky stuff here, right? And have I ever solved a problem like this before? I mean, not like this, but I've had to use Chinese remainder theorem for my maths courses, so not exactly like this, but something similar. Yeah, Timmy, show us your non-CRT solution. It's just iterating and checking if it works, right? Do you just like iterate and then you do +7 every time? It's gonna take a while, right? Link it, Timmy, please. Post a link. Took a while though, didn't it, huh? If you're just joining us, we just solved day 13 of Haskell of additive code. And we did using the Chinese remainder theorem, but it did take us a while. It took us a while to figure it out and get it right. But we did it, and let's see. It runs in 28 milliseconds on Windows with OBS and everything running. That's not bad. Not bad at all. Now we're waiting for Tim. He took my username to post the link. to his version, because I'd like to see it. But I think, you know, instead of just doing the Chinese remainder theorem thing, you kind of iterate through the numbers. You take +7 every time, right? Tim is out of contact right now. Ding 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 ding. So let's see, big MI a yeah, but at least we got it working, right? And map SND times quite few lines of code. Let's open Timmy's solution in my non. Ooh. Damn. That is one line. Yeah, so you do +7 every time, right? Or plus the first one, yeah, every time. And you check. So could you walk us through? The parser is not there. Does that turn out? What was the first value for you, Timmy? For us, it's 41. So I think Timmy's solution would. So PA here is a fold L1 reduce buses. So the ID is going to be 41. So it's going to add 41 every time, right? And then we simply check. So we do 41. We find the first one such that that is remainder is 0. Wait, so bus PP offset. Okay, yeah, so it starts off with 0. And then you kind of keep going by multiplying with the number you have so far. So I guess you kind of find the first time and then you keep going. Is that correct, Timmy? How long does it take to run? Yeah, it does, doesn't it? It kind of first find the first one and then you find you keep going, right? And then you find so you find if you solve the first case essentially, and then you keep going with the solution to the first case in mind. That works probably. Works pretty well. Right, Timmy? Can we get a runtime? Can we get a runtime? I love that Timmy though, he like created a data type for the bus. We just have an int, maybe int, right? Not so cool. Yeah, this is CRT. Because you find the first solution, right? And then you use that solution to keep the iteration going. And that's kind of what the Chinese remainder theorem is doing here. We have the two moduli and we have this solution. And then we kind of keep going, see? This is solving initial problem k equation, so similar problem with k minus 1 equation. So iterating the process, one eventually gets the solution to the initial problem. So you solve this, right? You find a1 comma 2, so you kind of merge the first two. But so you find the first two and then you keep going for the equations. And yeah. That's a good solution. I think it's better than mine. Mine is more mine is too abstract. I mean, I think, but this is like kind of very explicitly we're using Chinese remainder theorem here, so you know, we know it's going to work. But yeah. But yeah. But it wasn't really noticeable, so probably just a couple of milliseconds. But it's cool. Alright, y'all. I'm gonna leave you for today. Been 3 hours, which is a bit long, actually. And I'm gonna see if I can go for another walk. Another coronavirus walk. Well, that coronavirus is just like a quarantine walk, you know? You're allowed to... You go for a walk with someone else. You both wear masks, keep 2 meters apart. That's allowed. What I'm gonna do. If it's not allowed, some Icelanders can go ahead and report me. There's like a button on a web page where you can report. Yeah, I'm gonna do them later this week, maybe tomorrow. Not today. I was gonna do them today if this solution was dependent on it. But yeah, so if I'd finished this in you know, maybe an hour and a half or 2, then I would have continued. But I think it's 3 hours is quite long already, right? I'm just I'm a bit poofed, you know, to use a scientific term. But also, I like that the stream worked out. I think I hope the audio was good. I think the output was okay. I see that I have like 225 dropped frames in total over 3 hours. That's not a lot of frames at 60 FPS. So I think that it all worked out fine today. All right, thanks for today, and see you all tomorrow.